In this session, we will discuss about the important formulas in thermodynamics of chemistry. So, the first law of thermodynamics states that delta U is equals to Q plus W. Delta U is internal energy change, Q is heat energy given to system, and W is work done on the system. Relation between delta H and delta U. Delta H is equals to delta U plus PV. Delta H is change in enthalpy, delta U is change in internal energy, and delta PV is change in pressure and volume. And another important relation is delta H is equal to delta U plus delta NGRT. Here delta H is change in enthalpy, delta U is change in internal energy, delta NG is the change of gas molecules in the given reaction, and R is universal gas constant, T is temperature. When Ng is equals to 0, then delta H is equals to delta U, work done. W is equals to minus P external into delta V, that is V2 minus V1, that is final volume minus initial volume. This is the general formula for work done. When the reaction is reversible, then this formula is not used. When for reversible reaction, the formula used is W is equals to minus 2.303 into nRT log of V2 by V1, and another formula is W is equals to minus 2.303 log of P1 by P2. Here V2 and V1 are final volume and initial volume, and P1 and P2 are initial pressure and final pressure respectively. These two formulas are for reversible reaction. Heat capacity. Heat capacity is denoted by C. Heat capacity is the amount of heat energy required to change the temperature of the given system by 1 Kelvin or 1 degree Celsius. Heat capacity is C is equals to Q by dt, where C is the heat capacity, Q is the C is the heat capacity, Q is the heat given to system, and delta T is change in temperature. Specific heat capacity is the amount of heat energy required to increase the the specific heat capacity is the amount of heat energy required to increase the temperature of given system by 1 degree Celsius or 1 Kelvin in gram. So it is CS is equals to Q upon M delta T. Molar heat capacity Cm is equals to Q upon N delta T. Molar heat capacity is the amount of heat energy required to increase the temperature of 1 mole of substance or 1 mole of this matter by 1 degree Celsius or 1 Kelvin. Relation between Cp and Cv. Cp is the molar heat capacity at constant pressure, and Cv is the molar heat capacity at constant volume. So Cp is equal to R plus Cv, or Cp minus Cv is equal to R. Your R is universal gas constant. Cp and Cv, the difference of Cp and Cv is equals to R.